Google illustrated to the world how simple keyword combinations could open up a wide spectrum of content relevance. While many improvements have been made in leveraging keyword platforms, no one has changed the fundamental science of the co-occurrence of keywords model. We have. This video explains our science and introduces an entrepreneurial opportunity for linking similarity between text entities far beyond the search industry's football equals sports and dresses equals fashion approach to content relevance modeling. This video isn't a business plan per se, but is born of a business plan seeking investors for repurposing proven, enterprise-level software that has enabled game-changing inference into hidden truth for numerous companies for nearly 20 years. Versed in so what, who cares, why you, due diligence, this is a bit of an investor's tutorial. Part history, part education, part use case, and part vision. It makes the case for why taking currently shrink-wrap software to the cloud is a good idea for the right investor. Semiotic semantics informs us that the sounds and the names we give to things are relative cognitive mappings of those things. Keep this mantra in mind as I lead you through a use case from 2010 that still dramatically affects us all in direct and indirect economic ways. First published in Handbook of Research on Synthetic Emotions and Sociable Robotics, New Applications in Effective Computing and Artificial Intelligence, that sounds comprising human speech contain cognitive symbols of emotion originated with the paper A Theory of Emotions based on natural language semantics. It was a natural progression from a semiotic framework built around Dr. Talmudi's original paper, A Theory of Semantics based on Old Arabic, presented at the Linguistic Institute Conference at Stanford University in 1987. Semiotics is the study of symbols within semantics, the study of meaning. Here, the symbols are the sounds in the words of analyzed text, while the semantics come from a downstream modeling exercise, using the methodology's hierarchically weighted outputs as heuristic inputs to any inference-seeking application. Consider the following. Gather all the email exchanged by British Petroleum, Transocean, and the USA's Department of Mineral and Mining Services from January 2001 through July 2011. Analyze it with ontologica.com's semiotic toolkit. Then ask yourself, what information is being conveyed in all these reports? Are there recognizable symbols of their intent in all that content? Can we trust what they are telling us? Are they lying about their progress? Or maybe they're actually afraid of their own technology. Could we risk something communicated sliding by unnoticed because it just wasn't deemed to be all that critical by someone unqualified to make such a determination, or perhaps even biased enough to do so? How could we make such insights possible? By taking the field-tested software package Readware to the cloud, that's how. The shrink-wrap version of Readware has already enabled similar analysis seeking hidden inference on behalf of the likes of the following companies. In government, the Department of Justice, National Security Agency, the DEA, the CIA, the U.S. Marshals Service, Interpol, Germany's Federal Criminal Police Office, their analog of our FBI. Or companies here in North America like Feedster, Semiotica Inc., Aggregate Knowledge, and Canada's Open Text. And in Europe, Siemens, who used it for their Bonn to Berlin German capital project, Mercedes-Benz, BMW, Deutsche Bank, and ADAC, Germany's AAA. The annual text retrieval conference run by the National Institute of Standards was organized to create benchmarks for the products and offerings of participants in the search and indexing technology sector. This includes well-known, successful companies and distinguished universities like AT&T, MITRE, NCR, Xerox, MIT, Carnegie Mellon, Cambridge University, and Dartmouth College. 1998's Trek 7 featured 100 documents with an expert panel having predetermined the most appropriate topic for each. Figure 1 illustrates how Readware significantly outperformed the field with both the highest recall and precision scores. Our precision effort returned 93 out of the 100 documents featured. It turns out that several complications, including the British spellings of English words, slip by our parser and reduce our expected performance. We were pleased to get insight into that unexpected technical issue. We also beefed up our own scope of topical coverage after finding that some topical areas contain more natural ambiguity, like technology and fashion. We improved to 98 out of 100 documents identified in Trek 8's precision section. and by identifying close to 500 documents that no one else discovered, Reedware's amazing performance and unique recall was literally off the charts. After Trek 8, the ad hoc task was no longer offered. The intellectual force behind this framework is Dr. Tom Adi, a former professor of computer science at the University of Jeddah in Saudi Arabia, a talented linguist and highly respected Quranic scholar. This uniquely diverse skill set allowed him to notice two semantically critical passages in the Quran, the Muqam and the Mutashabih. A Muqam verse has no ambiguity in the understanding of its words. Such have an established meaning which prevents any other meaning. Thus, the Muqam means clear. A Mutashabih verse has meaning that is due to different possibilities, open to different interpretations, so can be defined as unclear or ambiguous. The Quran is over 1,400 years old and has been literally unchanged across that time. So this was a serendipitous find indeed. This linguistically stable, naturally oppositional semantic dataset provided a dependent space, a naturally occurring 0-1, yes-no, is-isn't mathematical modeling scenario. Such natural contrast allows the quantitative basis for differentiating clear from unclear as semantic opposites, enabling similarity calculations across the entire lexical space. The theory itself became more refined as a result of the software development effort. The predictions it makes are empirical validations of the theory's fitness, fulfilling a critical aspect of the scientific method, the ability of that hypothesis to make reliable, consistent predictions in the real world. Ported to 3 modern languages, English, German, and French, this first principle science has been verified across 17 modern languages to date. The phonemes, the atomic sounds of speech, have been determined to be identical across all these languages despite any triphone, a sequence of 3 phonemes that can be seen to comprise every word, differing radically. How do we know all this? How do we compute it? Matching humanity's aptitude for comprehending highly nuanced lexical content has long been the goal of artificial intelligence, far more complex than it seems whittled down to its constituent tasks. There is a gestalt to the human brain's process of parsing, decoding, classifying, ranking, then comprehending the many contextual possibilities inherent to what seems to be a simple passage of text. Reedware's application of the Adi theory of semantics begins with the matrix of sounds, or phonemes. 2 abstract objects model a symmetrical boundary condition, closed and open. Another set of abstractions represents symmetrical engagement, self, and others. The dot product of these 2 abstracted matrices of cognitive states yields a shorthand notation: inward, outward, engaged, unengaged. These, in turn, map directly back to the columns of the phoneme matrix as cognitive conditions. This led to a hierarchy for distilling the sounds of words to their most granular form, applying 12 different functions of the algebraic form f of x and g of y. Their domains are the sounds and the words, their operations resulting in topics related by weights, reflecting their relative similarity. This hierarchy is based on a cognitive triangle: assignment, manifestation, and containment. Imagine how statistical clustering works. We define a cluster center as a topic, assignment, a structure for relating other words around that definitional center via sound similarities. Cognitively applying these topics, manifestation, eventually constrains each topical cluster semantic range via distances from each topic center, containment, to all the others. This results in a uniquely clustered topical space generated from the sounds within the words themselves, yielding a relative cognitive mapping of the entire lexical space. Armed with the essentials about how Reedware's mathematical approach works, here are 3 lexical examples. The word judge, like all words, is a cognitive representation of an abstracted human conceptualization about the world. A process by which evidence is taken into account before a decision is made is a cognitive constant representing justice across every culture of humanity in any language. The words judge, calculate, and guess frame the natural contrast between words that started this theory on its way in the first place. The cognitive abstraction of the term hakim, judge, the dependent space, can be modeled by 2 separate inputs, the independent states, here hasaba, calculate, and karasa, guess. Note the triphones at work here, along with the different functions that mediate them according to the rules of precedence based on their roles, assignment, manifestation, and containment, and boundary polarities, inward, outward, engaged, and unengaged. Applying its semantic and cognitive theories, Reedware calculates the term judge as far more similar to the word calculate than the word guess. This is exactly what we'd expect of humanity's comprehension of judgment, a legal decision by someone performing calculations against the evidence, as opposed to someone who merely uses their own intuition to simply guess at an outcome. The next two examples demonstrate English versus German applications, both lexical doublets, not triplets, but clearly demonstrative of how the use of an automated, consistent, cognitively centric utility reveals hidden information unavailable to anyone or any system not fluent in both languages. While door and Tür represent the same physical object, Readware's semiotic toolkit reveals how the English usage embraces connectivity, while the German analog is subtly different, stressing the separation of two adjoining spaces, not their connection. Similarly, tree versus Baum reveal the cognitive differences between the English cognitive representation of a repeating branch structure, while German implies the recognition of a life form for that same physical object. The utility of such distinctions has clear import across a range of human applications. Readware is a classic client-server software architecture, packaged and sold in shrink-wrap software form. Sold one license at a time, this sales and accessibility model is utterly out of step with the internet world we live in these days. It's implemented in C++, Objective-C, and assembly language, a highly efficient, cloud-compatible architecture. All we lack is the web services interface to be able to surface streaming demand online. How it is that the emotional portent to text presented itself amidst the development of the ID theory of semantics harkens back to the stable, contrasting vocabulary of the Mukam and Mutashabeh. Emotions research is as old as humanity's hunt for answers to the question, why are we here? With both the research literature and self-reported state of humanity and the social literature rather voluminous in scope. As fractious and diverse as the arguments about what are, how to differentiate, and even how to quantify human emotions, there is no argument that no one can tell anyone else how they feel. The self-reporting of one's emotional state represents a naturally derived, high-contrast data set, much like the states of clear versus unclear afforded to cognitive processings, as those topical underpinnings to anything expressed lexically. We are semanticists, so our approach applies semantic methodologies to more fully explain evidence surfaced by all the competing schools of thought. Not setting out to form a theory of cognition, nor build upon it with a theory of emotions, our accurate predictions enticed us with the promise of something even more seminal. This path led to a reliable theory that explains both, while the predictive accuracy and consistency a model of both simply must accomplish. The notion of semantic universals became a driving influence in the study of general semantics after Alfred Korzybski, the recognized father of the field, published his groundbreaking work in the 1933 textbook, Science and Sanity. He founded the Institute of General Semantics in 1938, coining the famous term, "the map is not the territory," as the founding conundrum of this emerging scientific field in the process. René Magritte's painting, The Treachery of Images, called out this concept with its now famous label, "This is not a pipe," launching semantics into the public vocabulary and consciousness once and for all. The sounds and the names we give to things are relative cognitive mappings of those things. We believe this to be biologically true, witnessing our model of human cognition and emotion quantify, describe, and predict the semantic universal within human lexical discourse. Our approach points the way to a system of understanding without claiming understanding for ourselves. We are not two recent college graduates looking for speculative capitalization for a new idea with new technology in a new marketplace. Nor are we the byproduct of the entrepreneurial incubators, students of business merely seeking business to do. We are seasoned professionals seeking capital to take a proven, first principles, uniquely positioned technology to the internet world's current platform to reach an already huge but underserviced marketplace. A professor of computer science, chief scientist of an online recommendation engine, and intelligence officer of the Green Berets, we are a good bet in every measure of investor confidence. We're unique among the other industry players claiming to be able to do this, who have yet to prove their claim in the field with NLP technology that has repeatedly failed to deliver its promise of extracting meaning from text for over 30 years. In that context alone, ontologica.com is a hedge investment for those already banking on the online world to deliver commercial revenue. We seek the right investor with the right vision and a good fit to our own commercial goals and commitment to providing a rich and desperately needed service to humanity. Thanks for your time and attention. We relish the opportunity to share our detailed business plan with you.